a fraction represents a part of a whole or, more generally, any number of equal parts. When spoken in everyday English, a fraction describes how many parts of a certain size there are, for example, 1/2, 8/5, 3/4. A common, vulgar, or simple fraction consists of an integer numerator, displayed above a line, and a non-zero integer denominator, displayed below that line. Numerators and denominators are also used in fractions that are not common, including compound fractions, complex fractions, and mixed numerals. The numerator represents a number of equal parts, and the denominator, which cannot be zero, indicates how many of those parts make up a unit or a whole. For example, in the fraction 3/4, the numerator, 3, tells us that the fraction represents 3 equal parts, and the denominator, 4, tells us that 4 parts make up a whole. The picture to the right illustrates all 3/4 of a cake. Fractional numbers can also be written without using explicit numerators or denominators, by using decimals, percent signs, or negative exponents. An integer such as the number 7 can be thought of as having an implied denominator of 1, 7 equals 7/1. Other uses for fractions are to represent ratios and to represent division. Thus the fraction 3/4 is also used to represent the ratio 3:4 and the division 3/4. In mathematics, the set of all numbers which can be expressed in the form AB, where A and B are integers and B is not zero, is called the set of rational numbers and is represented by the symbol Q, which stands for quotient. The test for a number being a rational number is that it can be written in that form. However, the word fraction is also used to describe mathematical expressions that are not rational numbers, for example algebraic fractions, and expressions that contain irrational numbers, such as a2/2 and I/4. Vocabulary: in the examples 2/5 and 7/3, the slanting line is called a solidus or forward slash. In the examples and, the horizontal line is called a vinculum or, informally, a fraction bar. When reading fractions, it is customary in English to pronounce the denominator using the corresponding ordinal number, in plural if the numerator is not 1, as in fifths for fractions with a 5 in the denominator. Thus 3/5 is rendered as 3/5 and 5/32 as 5/32. This generally applies to whole number denominators greater than 2, though large denominators that are not powers of 10 are often rendered using the cardinal number. Thus, 5/123 might be rendered as 5/123, but is often 5/123. In contrast, because 1 million is a power of 10, 6/1 million is usually expressed as 6 millionths, or 6/1 millionths, rather than as 6/1 million. The denominators 1, 2 and 4 are special cases. The fraction 3/1 may be spoken of as 3 wholes. The denominator 2 is expressed as half. A 3/2 is -3/2 or -3/2. The fraction 3/4 may be either 3/4 or 3/4. Furthermore, since most fractions in prose function as adjectives, the fractional modifier is hyphenated. This is evident in standard prose in which one might write about every 2/10 of a mile, the quarter-mile run, or the 3/5 compromise. When the fraction's numerator is 1, then the word 1 may be omitted, such as every 10th of a second, or during the final quarter of the year. Forms of fractions: simple, common, or vulgar fractions. A simple fraction is a rational number written as AB or, where A and B are both integers. As with other fractions, the denominator cannot be zero. Examples include, and. Simple fractions can be positive or negative, proper, or improper. Compound fractions, complex fractions, mixed numerals, and decimals are not simple fractions, though, unless irrational, they can be evaluated to a simple fraction. Proper and improper fractions, common fractions can be classified as either proper or improper. When the numerator and the denominator are both positive, the fraction is called proper if the numerator is less than the denominator, and improper otherwise. In general, a common fraction is said to be a proper fraction if the absolute value of the fraction is strictly less than €, that is, if the fraction is greater than a 1 and less than 1. it is said to be an improper fraction, or sometimes informally top-heavy fraction, if the absolute value of the fraction is greater than or equal to 1. Examples of proper fractions are 2/3, -3/4, and 4/9. Examples of improper fractions are 9/4, -4/3, and 3/3. Mixed numbers. A mixed numeral is the sum of a non-zero integer and a proper fraction. This sum is implied without the use of any visible operators such as plus. For example, in referring to 2 entire cakes and 3/4 of another cake, the whole and fractional parts of the number are written next to each other. This is not to be confused with the algebra rule of implied multiplication. When two algebraic expressions are written next to each other, the operation of multiplication is said to be understood. In algebra, for example, is not a mixed number. Instead, multiplication is understood where. To avoid confusion, the multiplication is often explicitly expressed. So may be written as, or. An improper fraction is another way to write a whole plus a part. A mixed number can be converted to an improper fraction as follows: write the mixed number as a sum. Convert the whole number to an improper fraction with the same denominator as the fractional part. Add the fractions. The resulting sum is the improper fraction. In the example. Similarly, an improper fraction can be converted to a mixed number as follows: divide the numerator by the denominator. In the example, divide 11 by 4. 11 of 4 equals 2 with remainder 3. The quotient becomes the whole number part of the mixed number. The remainder becomes the numerator of the fractional part. In the example, 2 is the whole number part and 3 is the numerator of the fractional part. The new denominator is the same as the denominator of the improper fraction. In the example, they are both 4. Thus, mixed numbers can also be negative, as in, which equals. Ratios. A ratio is a relationship between two or more numbers that can be sometimes expressed as a fraction. Typically, a number of items are grouped and compared in a ratio, specifying numerically the relationship between each group. Ratios are expressed as group 1 to group 2 to group n. For example, if a car lot had 12 vehicles, of which 2 are white, 6 are red, and 4 are yellow, then the ratio of red to white to yellow cars is 6 to 2 to 4. The ratio of yellow cars to white cars is 4 to 2 and may be expressed as 4:2 or 2:1. A ratio is often converted to a fraction when it is expressed as a ratio to the whole. In the above example, the ratio of yellow cars to all the cars on the lot is 4:12 or 1:3. We can convert these ratios to a fraction and say that 4/12 of the cars or 1/3 of the cars in the lot are yellow. Therefore, if a person randomly chose one car on the lot, then there is a 1 in 3 chance or probability that it would be yellow. Reciprocals and the invisible denominator. The reciprocal of a fraction is another fraction with the numerator and denominator exchanged. The reciprocal of, for instance, is. The product of a fraction and its reciprocal is 1, hence the reciprocal is the multiplicative inverse of a fraction. Any integer can be written as a fraction with the number 1 as denominator. For example, 17 can be written as, where 1 is sometimes referred to as the invisible denominator. Therefore, every fraction or integer except for 0 has a reciprocal. The reciprocal of 17 is. Complex fractions, not to be confused with fractions involving complex numbers. In a complex fraction either the numerator, or the denominator, or both, is a fraction or a mixed number, corresponding to division of fractions. For example, and a complex fractions. To reduce a complex fraction to a simple fraction, treat the longest fraction line as representing division. For example, if, in a complex fraction, there is no clear way to tell which fraction lines takes precedence, then the expression is improperly formed, and ambiguous. Thus 520/40 is a poorly constructed mathematical expression, with multiple possible values. Compound fractions. A compound fraction is a fraction of a fraction, or any number of fractions connected with the word of, corresponding to multiplication of fractions. To reduce a compound fraction to a simple fraction, just carry out the multiplication. For example, of is a compound fraction, corresponding to. The terms compound fraction and complex fraction are closely related and sometimes one is used as a synonym for the other. Decimal fractions and percentages. A decimal fraction is a fraction whose denominator is not given explicitly, but is understood to be an integer power of 10. Decimal fractions are commonly expressed using decimal notation in which the implied denominator is determined by the number of digits to the right of a decimal separator, the appearance of which, a comma, depends on the locale. Thus for 0.75 the numerator is 75 and the implied denominator is 10 to the second power, viz. 100, because there are two digits to the right of the decimal separator. In decimal numbers greater than 1, the fractional part of the number is expressed by the digits to the right of the decimal. 3.75 can be written either as an improper fraction, 375/100, or as a mixed number. Decimal fractions can also be expressed using scientific notation with negative exponents, such as 6.023a, 10^7, which represents 0.0000006023. The 10^7 represents a denominator of 107. Dividing by 107 moves the decimal point 7 places to the left. Decimal fractions with infinitely many digits to the right of the decimal separator represent an infinite series. For example, 1/3 equals 0.333. Represents the infinite series 3/10 plus 3/100 plus 3/1000 plus. Another kind of fraction is the percentage, in which the implied denominator is always 100. Thus, 51% means 51/100. Percentages greater than 100 or less than 0 are treated in the same way. For example, 311% equals 311/100. And a 27% equals a 27/100. The related concept of per mille or parts per thousand has an implied denominator of 1000, while the more general parts per notation, as in 75 parts per million, means that the proportion is 75/1 million. Whether common fractions or decimal fractions are used is often a matter of taste and context. Common fractions are used most often when the denominator is relatively small. By mental calculation, it is easier to multiply 16 by 3/16 than to do the same calculation using the fraction's decimal equivalent. And it is more accurate to multiply 15 by 1/3, for example, than it is to multiply 15 by any decimal approximation of 1/3. Monetary values are commonly expressed as decimal fractions, for example $3.75. However, as noted above, in pre-decimal British currency, shillings and pence were often given the form of a fraction, as, for example 3/6 meaning 3 shillings and 6 pence, and having no relationship to the fraction 3/6. Special cases, a unit fraction is a vulgar fraction with a numerator of 1, for example. Unit fractions can also be expressed using negative exponents, as in 2/1 which represents 1/2. And 2/2 which represents 1/22, or 1/4. An Egyptian fraction is the sum of distinct positive unit fractions, for example. This definition derives from the fact that the ancient Egyptians expressed all fractions except, and in this manner. Every positive rational number can be expanded as an Egyptian fraction. For example, can be written as any positive rational number can be written as a sum of unit fractions in infinitely many ways. Two ways to write are and. A dyadic fraction is a vulgar fraction in which the denominator is a power of 2, for example. Arithmetic with fractions, like whole numbers, fractions obey the commutative, associative, and distributive laws, and the rule against division by zero. Equivalent fractions, multiplying the numerator and denominator of a fraction by the same number results in a fraction that is equivalent to the original fraction. This is true because for any non-zero number, the fraction. Therefore, multiplying by is equivalent to multiplying by 1, and any number multiplied by 1 has the same value as the original number. By way of an example, start with the fraction. When the numerator and denominator are both multiplied by 2, the result is, which has the same value as. To picture this visually, imagine cutting a cake into 4 pieces. two of the pieces together make up half the cake. Dividing the numerator and denominator of a fraction by the same non-zero number will also yield an equivalent fraction. This is called reducing or simplifying the fraction. A simple fraction in which the numerator and denominator occur prime is said to be irreducible, in lowest terms, or in simplest terms. For example, is not in lowest terms because both 3 and 9 can be exactly divided by 3. In contrast, is in lowest terms the only positive integer that goes into both 3 and 8 evenly is 1. Using these rules, we can show that equals. A common fraction can be reduced to lowest terms by dividing both the numerator and denominator by their greatest common divisor. For example, as the greatest common divisor of 63 and 462 is 21, the fraction can be reduced to lowest terms by dividing the numerator and denominator by 21. The Euclidean algorithm gives a method for finding the greatest common divisor of any two positive integers. Comparing fractions with the same denominator only requires comparing the numerators. Because 3 greater than 2. If two positive fractions have the same numerator, then the fraction with a smaller denominator is the larger number. When a whole is divided into equal pieces, if fewer equal pieces are needed to make up the whole, then each piece must be larger. When two positive fractions have the same numerator, they represent the same number of parts, but in the fraction with a smaller denominator, the parts are larger. One way to compare fractions with different numerators and denominators is to find a common denominator. To compare and, these are converted to and. Then d is a common denominator and the numerators add and bc can be compared. A gives, it is not necessary to determine the value of the common denominator to compare fractions. This shortcut is known as cross-multiplying. You can just compare add and bc, without computing the denominator. A multiply top and bottom of each fraction by the denominator of the other fraction, to get a common denominator, A. The denominators are now the same, but it is not necessary to calculate their value. Only the numerators need to be compared. Since 5a, 17 is greater than 4a, 18. Also note that every negative number, including negative fractions, is less than 0, and every positive number, including positive fractions, is greater than 0, so every negative fraction is less than any positive fraction. Addition. The first rule of addition is that only like quantities can be added. For example, various quantities of quarters. Unlike quantities, such as adding thirds to quarters, must first be converted to like quantities as described below. Imagine a pocket containing 2 quarters, and another pocket containing 3 quarters. In total, there are 5 quarters. Since 4 quarters is equivalent to 1, this can be represented as follows. Adding unlike quantities. To add fractions containing unlike quantities, it is necessary to convert all amounts to like quantities. It is easy to work out the chosen type of fraction to convert to. Simply multiply together the two denominators of each fraction. For adding quarters to thirds, both types of fraction are converted to twelfths, thus. Consider adding the following two quantities. First, convert into fifteenths by multiplying both the numerator and denominator by 3. Since equals 1, multiplication by does not change the value of the fraction. Second, convert into fifteenths by multiplying both the numerator and denominator by 5. Now it can be seen that is equivalent to. This method can be expressed algebraically. And for expressions consisting of the addition of 3 fractions. This method always works, but sometimes there is a smaller denominator that can be used. For example, to add in the denominator 48 can be used, but the smaller denominator 12 may also be used, being the least common multiple of 4 and 12. Subtraction. The process for subtracting fractions is, in essence, the same as that of adding them. Find a common denominator, and change each fraction to an equivalent fraction with the chosen common denominator. The resulting fraction will have that denominator, and its numerator will be the result of subtracting the numerators of the original fractions. For instance, multiplication, multiplying a fraction by another fraction. To multiply fractions, multiply the numerators and multiply the denominators. Thus, why does this work? First, consider 1/3 of 1/4. Using the example of a cake, if 3 small slices of equal size make up a quarter, and 4 quarters make up a whole, 12 of these small, equal slices make up a whole. Therefore 1/3 of a quarter is a 12th. Now consider the numerators. The first fraction, 2/3, is twice as large as 1/3. Since 1/3 of a quarter is 1/12, 2/3 of a quarter is 2/12. The second fraction, 3/4, is 3 times as large as 1/4, so 2/3 of 3/4 is 3 times as large as 2/3 of 1/4. Thus 2/3 times 3/4 is 6/12. A shortcut for multiplying fractions is called cancellation. In effect, we reduce the answer to lowest terms during multiplication. For example, a 2 is a common factor in both the numerator of the left fraction and the denominator of the right and is divided out of both. 3 is a common factor of the left denominator and right numerator and is divided out of both. Multiplying a fraction by a whole number, place the whole number over 1 and multiply. This method works because the fraction 6/1 means 6 equal parts, each one of which is a whole. Mixed numbers. When multiplying mixed numbers, it's best to convert the mixed number into an improper fraction. For example, in other words, is the same as, making 11 quarters in total and 33 quarters is, since 8 cakes, each made of quarters, is 32 quarters in total. Division. To divide a fraction by a whole number, you may either divide the numerator by the number, if it goes evenly into the numerator, or multiply the denominator by the number. For example, equals and also equals, which reduces to. To divide a number by a fraction, multiply that number by the reciprocal of that fraction. Thus, converting between decimals and fractions, to change a common fraction to a decimal, divide the denominator into the numerator. Round the answer to the desired accuracy. For example, to change 1/4 to a decimal, divide 4 into 1.00, to obtain 0.25. To change 1/3 to a decimal, divide 3 into 1.0000. And stop when the desired accuracy is obtained. Note that 1/4 can be written exactly with 2 decimal digits, while 1/3 cannot be written exactly with any finite number of decimal digits. To change a decimal to a fraction, write in the denominator a 1 followed by as many zeros as there are digits to the right of the decimal point, and write in the numerator all the digits in the original decimal, omitting the decimal point. Thus 12.3456 equals 123,456/10,000. Converting repeating decimals to fractions. Decimal numbers, while arguably more useful to work with when performing calculations, sometimes lack the precision that common fractions have. Sometimes an infinite repeating decimal is required to reach the same precision. Thus, it is often useful to convert repeating decimals into fractions. The preferred way to indicate a repeating decimal is to place a bar over the digits that repeat. For example, 0.789 equals 0.789789789 euro for repeating patterns where the repeating pattern begins immediately after the decimal point. A simple division of the pattern by the same number of nines as numbers it has will suffice. For example, 0.5 equals 5/9, 0.62 equals 62/99, 0.264 equals 264/999, 0.6291 equals 6291 9999. In case leading zeros precede the pattern, the nines are suffixed by the same number of trailing zeros, 0.05 equals 5/90, 0.000392 equals 392/999,000. 0.0012 equals 12/9,900ths. In case a non-repeating set of decimals precede the pattern, we can write it as the sum of the non-repeating and repeating parts, respectively, 0.1523 plus 0.0000987, then, convert both parts to fractions, and add them using the methods described above. 1523 10,000ths plus 987 9,990,000ths equals 1,522,464 / 9,990,000. Fractions in abstract mathematics. In addition to being of great practical importance, fractions are also studied by mathematicians, who check that the rules for fractions given above are consistent and reliable. Mathematicians define a fraction as an ordered pair of integers a and b, a perm L0, for which the operations addition, subtraction, multiplication, and division are defined as follows. In addition, an equivalence relation is specified as follows, if and only if. These definitions agree in every case with the definitions given above. Only the notation is different. More generally, a and b may be elements of any integral domain R, in which case a fraction is an element of the field of fractions of R. For example, when a and b are polynomials and one indeterminate, the field of fractions is the field of rational fractions. When a and b are integers, the field of fractions is the field of rational numbers. Algebraic fractions. An algebraic fraction is the indicated quotient of two algebraic expressions. Two examples of algebraic fractions are and. Algebraic fractions are subject to the same laws as arithmetic fractions. If the numerator and the denominator are polynomials, as in, the algebraic fraction is called a rational fraction. An irrational fraction is one that contains the variable under a fractional exponent or root, as in. The terminology used to describe algebraic fractions is similar to that used for ordinary fractions. For example, an algebraic fraction is in lowest terms if the only factors common to the numerator and the denominator are 1 and a 1. An algebraic fraction whose numerator or denominator, or both, contain a fraction, such as, is called a complex fraction. Rational numbers are the quotient field of integers. Rational expressions are the quotient field of the polynomials. Since a coefficient is a polynomial of degree 0, a radical expression such as a2/2 is a rational fraction. Another example is, the radian measure of a right angle. The term partial fraction is used when decomposing rational expressions into sums. The goal is to write the rational expression as the sum of other rational expressions with denominators of lesser degree. For example, the rational expression can be rewritten as the sum of two fractions, plus. This is useful in many areas such as integral calculus and differential equations. Radical expressions. A fraction may also contain radicals in the numerator and/or the denominator. If the denominator contains radicals, it can be helpful to rationalize it, especially if further operations, such as adding or comparing that fraction to another, are to be carried out. It is also more convenient if division is to be done manually. When the denominator is a monomial square root, it can be rationalized by multiplying both the top and the bottom of the fraction by the denominator. The process of rationalization of binomial denominators involves multiplying the top and the bottom of a fraction by the conjugate of the denominator so that the denominator becomes a rational number. For example, even if this process results in the numerator being irrational, like in the examples above, the process may still facilitate subsequent manipulations by reducing the number of irrationals one has to work with in the denominator. Typographical variations. In computer displays and typography, simple fractions are sometimes printed as a single character, for example a 1/2. See the article on number forms for information on doing this in Unicode. Scientific publishing distinguishes 4 ways to set fractions, together with guidelines on use. Special fractions, fractions that are presented as a single character with a slanted bar, with roughly the same height and width as other characters in the text. Generally used for simple fractions, such as, a 1/2, a 1/4, and a 3/4. Since the numerals are smaller, legibility can be an issue, especially for small-sized fonts. These are not used in modern mathematical notation, but in other contexts. Case fractions, similar to special fractions, these are rendered as a single typographical character, but with a horizontal bar, thus making them upright. An example would be, but rendered with the same height as other characters. Some sources include all rendering of fractions as case fractions if they take only one typographical space, regardless of the direction of the bar. Shilling fractions, 1/2, so called because this notation was used for pre-decimal British currency, as in February 6 for a half-crown, meaning 2 shillings and 6 pence. While the notation 2 shillings and 6 pence did not represent a fraction, the / is now used in fractions, especially for fractions in line with prose, to avoid uneven lines. It is also used for fractions within fractions or within exponents to increase legibility. Fractions written this way, also known as piece fractions, are written all on one typographical line, but take 3 or more typographical spaces. Built-up fractions. This notation uses 2 or more lines of ordinary text, and results in a variation in spacing between lines when included within other text. While large and legible, these can be disruptive, particularly for simple fractions or within complex fractions. History. The earliest fractions were reciprocals of integers, ancient symbols representing 1 part of 2, 1 part of 3, 1 part of 4, and so on. The Egyptians used Egyptian fractions circa 1000 BC. About 4,000 years ago Egyptians divided with fractions using slightly different methods. They used least common multiples with unit fractions. Their methods gave the same answer as modern methods. The Egyptians also had a different notation for dyadic fractions in the Akhmim wooden tablet and several rhymed mathematical papyrus problems. The Greeks used unit fractions and later continued fractions, and followers of the Greek philosopher Pythagoras, circa 530 BC, discovered that the square root of 2 cannot be expressed as a fraction. In 150 BC Jain mathematicians in India wrote the Sthananga Sutra, which contains work on the theory of numbers, arithmetical operations, operations with fractions. The method of putting one number below the other and computing fractions first appeared in Aryabhata's work around AD 499. In Sanskrit literature, fractions, or rational numbers, were always expressed by an integer followed by a fraction. When the integer is written on a line, the fraction is placed below it and is itself written on 2 lines, the numerator called amza part on the first line, the denominator called shida e divisor a on the second below. If the fraction is written without any particular additional sign, one understands that it is added to the integer above it. If it is marked by a small circle or a cross placed on its right, one understands that it is subtracted from the integer. For example, Bhaskara I writes, A7 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 A6, a 10 that is, 6 1 2, 1 1 1 6, 4 5. 9, to denote 6 plus 1 over 4, 1 plus 1 over 5, and 2 1/9. Al-Hassawar, a Muslim mathematician from Fez, Morocco specializing in Islamic inheritance jurisprudence during the 12th century, first mentions the use of a fractional bar, where numerators and denominators are separated by a horizontal bar. In his discussion he writes, for example, if you were told to write 3/5 and 1/3 of a fifth, write thus. This same fractional notation appears soon after in the work of Leonardo Fibonacci in the 13th century. In discussing the origins of decimal fractions, Dirk Jan Struik states, the introduction of decimal fractions as a common computational practice can be dated back to the Flemish pamphlet De Theend, published at Leiden in 1585, together with a French translation, L'Ardisme, by the Flemish mathematician Simon Stevin, then settled in the northern Netherlands. It is true that decimal fractions were used by the Chinese many centuries before Stevin, and that the Persian astronomer Al-Khashar used both decimal and sexagesimal fractions with great ease in his Key to Arithmetic. While the Persian mathematician Jamshid Al-Khashar claimed to have discovered decimal fractions himself in the 15th century, J. Lennart Bargren notes that he was mistaken, as decimal fractions were first used 5 centuries before him by the Baghdadi mathematician Abul Hasan al-Aqladisi as early as the 10th century. In formal education, Pedagogical tools. In primary schools, fractions have been demonstrated through Quizware rods, fraction bars, fraction strips, fraction circles, paper, pattern blocks, pie-shaped pieces, plastic rectangles, grid paper, dot paper, geoboards, counters and computer software. Documents for teachers. Several states in the United States have adopted learning trajectories from the Common Core State Standards Initiative's Guidelines for Mathematics Education. Aside from sequencing the learning of fractions and operations with fractions, the document provides the following definition of a fraction: a number expressible in the form where is a whole number and is a positive whole number. The document itself also refers to negative fractions. See also, continued fraction, references. External links, fraction, arithmetical. The Online Encyclopedia of Mathematics. Werenstein, Eric W., Fraction, MathWorld. Fraction. Encyclopedia Britannica. Fraction. Citizendium. Fraction. Planet Math. Online program for exact conversion between fractions and decimals.